So good afternoon, everybody. Goedenavond to the Dutch people in the room. So I actually had the pleasure of living in the Netherlands for 4 years, many years ago. Unfortunately, this is my first time in Rotterdam, having only lived 20 kilometers up the road. So I'm sad to say it's taken me another 15 years to get here. Yeah. So I apologize on behalf of Steve for him not being able to be here today. Unfortunately, he got held up on something in the States, so he's asked me to fill in and do his presentation for him. So what I'd like to do today, really, over the next 15 minutes is look at how we see geospatial information today really transforming industries out there in the marketplace. And we'll go through what we mean by transformation, and then we'll look at some of the examples from those specific industries. So really the first one comes down to, given a definition of transformation, it's good to hear Sanjay talking about transformation in his talk, versus a transformation technology as opposed to an enhancing technology, whereby really an enhancing technology is just looking at providing significant incremental benefits, but it really doesn't alter those underlying roles or relationships in a profession or an organization. Whereas if we look at something that is transforming an industry, it really is changing the structure, all the roles of that industry or profession. If we look at some of the examples here of other technologies that have transformed industries over history, we can look at the marine chronometer, which changed the way that mariners were able to navigate around the world many, many years ago, going through the cotton gin into cotton agriculture, through the water frame, the Haber process in terms of fertilizer for agriculture, and also the most recent one that we've all experienced in our lifetimes has been the internet, and how that has transformed the way a lot of us go about our day-to-day business today. And we really see now the ability for utilization of geospatial information more as an enabling technology as opposed to an industry, because it's enabling multiple industries to transform the way that they operate today. So what are we seeing in terms of the new technologies are enabling significant productivity and quality of data to be gathered? If we think back maybe only 10 or 15 years into the amount of data that be collected at a specific time, so the amount of data today that can be collected, or the number of points per day, when you look at some of the LiDAR capabilities, the mobile mapping, mobile survey capabilities, we're able to collect tens of millions of points in a very, very short space of time versus maybe only collecting a few points a day that we saw a few years ago. What this is really driving to is that cost per point is driving down dramatically, and the value of the accuracy is decreasing. So we're getting greater accuracy for a less or a lower level of spend in terms of the data we're collecting or where that data is coming from. The data is coming from multiple sources. It isn't necessarily being collected by that geospatial practitioner anymore. It may be collated through a crowdsourcing technique rather than as an expert going out there in the field. We're really seeing now that technology convergence is taking place as we migrate into this digital era, that really is, that digital era is enabling the transformation to take place. And if we look at some of the technology trends that are driving that, it goes through the sensors that we all know, a lot of us know, but we're seeing significant sensor integration now, where you may find an IMU being integrated with camera, laser technology, GNSS technology into one data capture sensor. At the same time, we're seeing significant improvement in processing power and in terms of the software intelligence that ultimately is driving the ability of real-time updates to take place. And that together with the connectivity is enabling the information to be supplied far faster to the users or immediately where appropriate. If we look at some of the examples we'll have from an industry perspective, where we see that real-time data flow going backwards and forwards from machines to a central repository to be analyzed and maybe passed back out to the machine again. That can happen in seconds or minutes, depending upon the decision-making capabilities or requirements. And then we look at the ability now on data storage for the management of big data, but it also means that the data can be processed far quicker than it has in the past. And then we get down into the aspect from a user perspective, which is becoming more and more critical, is really looking at the visualization and the interaction of the user with the data. We're not necessarily now just looking at 2D maps, but there's far more requirement for 3D models, the fly-throughs of the digital cities, etc., for our way of visualizing the information and helping us to interpret the data. So sensors continue to remain an active area of development for the manufacturers that are involved in this space. But again, we're beginning to see a significant convergence of that sensor capability into more integrated sensors. And there's a session tomorrow talking about convergence where one of my colleagues will go from a Trimble perspective in more detail around this. But really we're looking at bringing these together to create a greater capability to capture the data from various aspects, and then we have these big data files that we then need to manage and extract the appropriate data to support the decision making for that particular industry. And that differs from business to business. And the session we've just been in for the last day and a half, we've had different industries talking and local government organizations discussing how they use the data, the return on investment, how they monetize the data. And really it does depend on how they're driven and what drives that organization to determine really how that data adds value to the organization and what is the true return on investment or monetization of that data. And again, really this processing power revolution really has impacted that geospatial work process, and it's enabling us to do far more things today than we ever thought possible, or thought possible maybe 5 to 10 years ago, around the collection of the data and the analytics that can take place on the data, whether that is change detection, data extraction, visual extraction of information coming from data sources that supports industries in ways that they probably didn't think they could be supported 5 to 10 years ago. And from a geospatial practitioner perspective, it started to change the way that we operate as well. So from the old style of doing things and really from the comfort zone perspective of the data collection, going out into the field, collecting the data, coming back, interpreting the data and providing the quality control around it. But now you may not actually be in control of that data. That data could be coming from a different source. The surveyor, the individual who's driving the van down the street from a mobile mapping perspective may not be a geospatial expert. It's just somebody who's in a vehicle driving down the street. But somebody somewhere needs to provide that data validation at the end of the day and then provide the analytical tools or apply the analytical tools to the data and understand how that data is going to be applied into specific industries. But that data that's captured could actually be used in multiple areas. So if you are a survey and engineering company who's capturing that amount of data, you may use that 5, 6, 7 times now for different clients at the end of the day, where you've captured that data once to meet your needs and ultimately to meet their needs. And really the key skills required now are understanding the context of the data, managing the complexity around the data, and then the overall data management and the extraction of the key information. So how we see the geospatial value proposition now, it's a slight change for those who've been in the session from the slide I showed yesterday, but really we migrate from the left of the screen where you look at the positioning and sensor capability from a data capture perspective, then you get into the connectivity and the processing of the data, but really the key value for the end customers and how they apply it in their industries comes down to the modeling of the data, the farm management, field inspection, getting into mechanical or structural design if you're talking about vertical buildings, and then really getting into the analytics and the decision support. So what information, or how do I want to use that information at the end of the day to provide incremental value to my business? How is it really going to help me become more productive, more efficient in the way I work? And that could be around yield management on a farm. It could be fleet analytics in a transport and locations application where you can look at the diagnostics of the engine, the way the driver is driving, has the vehicle stopped in a location where it shouldn't stop, has the rear door been opened, potentially has produce been taken off there where it shouldn't have been taken off. You can get down into cost analysis, time analysis around a project, or looking at the compliance aspect from a design aspect of doing the as-built versus the original design. So again, the true value to the industries is up on the right-hand side here in terms of how they can utilize that data and apply it into their specific businesses or industries. So there's multiple industries here where we see the transformation starting to take place. The top layer here on the top 5 is where we tend to focus at the moment. I'll go into more detail on each of these industries. And then we're starting to explore again what we can do in some of the rail, water utilities, electric utilities, mining, etc., and other opportunities to take geospatial information into those industries into a far greater depth than they may have used it in the past, and then understand how that can help them become more effective and more productive in the way they operate. So if we start with the work of the geospatial professionals, which is close to a lot of people's hearts in the room here, But as the capabilities continue to advance, the benefits that's providing to the users is they can actually complete the projects in a far quicker way than they have done in the past. But they're also collecting data that maybe they don't need for that particular project, but they can utilize in the future. So we have a customer in North Carolina who has one of these mobile mapping vans, who whenever he's driving out to a specific job is continuously collecting data. And then when the next call comes in for somebody who wants some information from the route he's already taken, he hasn't got to go back out to collect that data. He's already got it on his file or in his disk storage, and he utilizes that data, and he's becoming far more effective in the way he's operating. Also, I'm talking to the gentleman from Caltrans this afternoon, some of the capabilities are now coming around, LiDAR, UAVs, etc., are improving the safety capability for the field worker. So there's less time actually spent out in the field in more dangerous situations, so therefore improving the safety of the field worker. So a number of benefits that we're seeing today for the geospatial professional. Then we migrate into the heavy civil construction, so road, rail, airport construction, and the adoption of 3D machine control technology on the site, but also looking at a constructed site model, a construction site model where really you see the data flowing backwards and forwards. So the site has internet capability, there's models on the machine, there's models in the office. They probably haven't used a surveyor to stake out the site anymore. The design is put onto the machine and they go out and do it for the earthworks. But as they move up the grade and the cost of materials becomes more expensive, the fact that you get a more accurate process to build the road, utilizing less materials or less of the expensive materials, you're actually reducing the cost to the operator and the cost to the owner, and you're reducing the amount of rework as well. So significant benefits that are taking place for both the contractor and the owner. And some of the metrics here we're seeing now are probably 25 to 30% reduction in rework on some of the major construction projects. So that's a significant value to both the contractor and the end customer, and that's a tangible value that can be measured. Again, you can get into site worker safety, which is probably more of an intangible. You can measure, or you can hopefully get down to zero accidents on site by using some of the capabilities. At the same time, you're able to manage the amount of fuel that's used, understand the fuel costs, and hopefully begin to lower the fuel costs from an environmental impact at the same time. Then we get into the building construction, so putting a building like this together from a vertical construction. So looking at really building that constructible model that takes place in the office from the design through putting together the whole 3D model using the building information modeling capabilities, we're able to identify and track all those potential clashes in the model in the office before you get out on site. So anybody who's been involved in vertical construction, looking at building construction, multiple times you come out on site, you've got your 2D plans, you go and start to put the construction process together and realize you're trying to run the wastewater right through where a steel girder is positioned. And then you've got to do all the rework around that to reposition everything. By utilizing the model now, you can actually do that in the office, but then you actually go from a 3D model to a 5D model. It's not just getting the X, Y, Z on the model, you can now build in the cost and time as well. Then as potential change orders come in, you get an immediate update on what it's going to cost you to perform those change orders, the materials that are needed. Do I need to put a new order out on the fabrication plant, and the time it's going to take to complete the building. And then you can go from the model, you can actually load that up onto data collectors or field tools to go out onto the site to accurately position exactly where each nut and bolt needs to be positioned. So there's significant benefits we're seeing now, both from faster completion of the project, again a significant reduction in rework and therefore in labor cost, but also a vast improvement in the quality of the finish, and also you now have a 3D model of where everything is. You can do an as-built from a scanning perspective, so you have your as-built compared with your model that you then store on data for all the ongoing facilities maintenance. So we've got an example, a little video in a minute, but if you look at that building in the background there, so we just completed a building project in Colorado for ourselves, which from breaking ground to completing that building has taken 12 months. And we moved in last week, we broke ground in May 2012. We've actually used that as a showcase for all the various technologies that can be applied to putting a building together. from the survey stakeout to utilizing the machine control tools on the earthworks, right through the whole model for the building information, down to each of the trades coming on site using the model for the mechanical, electrical, plumbing, utilities, etc. We've also used that to show some of the benefits and true returns that you can get from utilizing the capability. And the short video we'll show now is just one example of the value of utilizing the current capabilities versus the traditional methods. And this relates to laying out the wall fixtures for one floor of the building. So just from that short example, you can see the significant productivity enhancements that were gained by utilizing the geospatial information and the capabilities that exist today. And we will have, as we build out now the information that we've captured through the process, be able to give more and more examples of how this capability can be applied into the vertical construction market. Another area which is significant for Trimble, and again, where over the last 5 to 10 years we've seen a significant transformation, is in the agriculture market. Again, this concept of a connected farm where the information is flowing backwards and forwards between the machines out in the field and the heart of the farm, or where the farm office is based. And again, we're looking at the precision guidance for the planting of the seed, the measurement of the harvest that's coming off the land, but also in the application of the fertilizer and the pesticide. You're not having to spray it across every plant now. You can actually go along and, using some visual detection techniques, gauge which plants either need fertilizer or need pesticide and apply them to that specific plant only. So again, you're seeing a significant reduction in the input costs for the farmer, as well as you're managing the crop yields to the maximum efficiency, and able to measure where the crop yields may be dropping slightly, and then understand if there's something wrong with the soil, so you can go back in between the crops to address the issues there. So again, the whole agriculture business has seen a significant amount of transformation over the last 5 to 10 years with the introduction of geospatial capabilities. And the last one is in the transportation and logistics. Again, looking at those long-haul trucking fleets and how utilizing the geospatial information around those fleets can drive significant improvements in the efficiency, operating efficiencies of those organizations. And from the data we're seeing, they're looking at a 30% improvement in the productivity of the organizations, 30% improvement in the asset utilization, and in the overall regulatory compliance, which again was a significant issue, not in the discussions we've had over the last day and a half, around auditability and having that track and trace capability of exactly who did what, where, and when, and having that in a digital format. And again, seeing significant reductions in the fuel use, the CO2 emissions, and the claims costs for these hauliers as well. So again, the geospatial information is helping to transform that transportation and logistics industry. So just a summary, in terms of the benefits that we see that are resulting from this transformation that's taken place. So there are the economic breakthroughs, so we are seeing increased productivity, incremental return on investments. We've seen the higher yields and we've seen a reduction in the input costs, whether that's material on a construction project, material or fertilizer and pesticides going into a farm, and the increased utilization of both assets, whether they be physical assets or field workers. Another key area is the improved quality, safety and compliance. So looking at the quality of the data and having that audit trail, the operator and worker safety out in the field, and the ability to measure against the regulatory compliance that may exist for a particular industry or in a particular country. And then down to the reduction in the environmental impact, whether it's in fossil fuels that are used, chemicals and water, or in the amount of waste on a particular project, and the better information that's provided around it. So I hope that's given you a little insight into how we perceive that geospatial information is helping to transform a number of industries. I hope you enjoy the rest of the week and the rest of the evening. Thank you very much.